In this video, I will solve this limit here. When you're given a limit, the first thing you want to do is plug in whatever the value that x is approaching to into the limit first to see if you get the answer. If you get the answer, you're done. If you don't get the answer you want, you have to do more work to get to the answer. So let's directly plug 0 into x here to see what we get. So here, sine times 0 times 1 minus cosine 0 all over 2 times 0 squared. Okay, sine 0 is 0. Now times 1 minus cosine 0 is 1. All over 2 times 0 is 0. Now 1 minus 1 is 0. 0 times 0 is 0. 0 over 0. So that's not the answer we want. Okay, that means we have to do more work now to get to the answer. How should we do this? For this limit, I will break up the 2x squared into 2x and x. Let's see how we can do that. So the first thing is limit as x approaches 0, sine x over 2x, right? Then what we have left is 1 minus cosine of x over x times 1 minus cosine of x over x, right? 2x times x is 2x squared. Now, I would use the property of limit and distribute the limit to both of these terms. So I have limit as x approaches 0, sine x over 2x times limit as x approaches 0, 1 minus cosine of x over x. Now, this is just a constant 1 over 2. I will move it out of the limit. So 1 over 2 times limit as x approaches 0, sine x over x times limit as x approaches 0, 1 minus cosine of x over x. Okay, now, of course, if we put 0 into x here, each of these terms will be 0 over 0. That's not what we want. We have to do more work to find out what these two limits are. Then how do we do that? Well, let's find out what limit as x approaches 0 sine x over x is first. And we'll use the squeeze theorem to do that. Okay, so here. Let's find out limit as x approaches 0 sine x over x. Okay, let's do that first. Now, in front of you, there's a unit circle here. And the unit circle has radius equals to 1. Okay, so now I'm going to draw the radius of this circle. Here. That's the radius of the circle. And I can draw a line down here. Right? Extend from here to the x-axis. Well, I mean, this is the plan, right? So I have to extend another line here. And of course, right, we call that angle x here. Because the angle is x here, right? Okay. So now, let's call this side A and let's call this side B, okay? So we will not label this axis here, okay? Because we're using angle as x here, so I'm not going to label this axis, okay? Let's say this is just a plane and we have a unit circle lying on this plane here, okay? Now, what's the value of A and what's the value of B? We can use the trigonometry to figure this out, right? We can say that, right? Sine x is equal to A over R. So sine x is equal to A over R. Then A is equal to R times sine x. So R sine x And we know that r is equal to 1. So a is equal to sine x. Okay, what's b here? We can say that cosine of x is equal to b over r. So cosine x is equal to b over r. Then b is equal to r times cosine of x. And r is equal to 1. Then b is equal to cosine of x. Okay, now can we write this? This side is sine x. And this side here is cosine x. Okay, now I'm going to draw another line here. Extend from the axis up here. And then extend this one. Like this. Okay, so what you see here is there's a smaller triangle here and there's a sector here, right? So here, right? So that's a smaller triangle and here's the sector and there's a bigger triangle here. Okay, so what we know here is the area of this smaller triangle is less than or equal to the area of this sector and is less than or equal to the area of this larger triangle. Okay, so let's do this. Now we have a smaller triangle here. And we know that, right? The hypotenuse is r. And this side here is sine x. And this side here is cosine of x, right? According to this. This one here. Now, there's a sector here. And then we have a larger triangle here. This one. Okay. Now, what's the area of this smaller triangle? The area of a triangle is the base times height divided by 2, right? So this area here is sine x times cosine of x divided by 2. Okay, what's the area of the sector here? Now we know that this is angle x here. And this is the radius, r, right? From this diagram here, okay? So angle x and radius r. The area of a sector is usually, right? Half times the angle, which is x, right? Times r squared. Now, what's the area of the triangle here? The bigger triangle. And this is longer than r, right? Because it extended out here, right? So it's longer than r, okay? Maybe I should use a different color just to indicate this. Let me use green here. Right? Like that. And for the sector, let me use blue here. So this one here is blue, okay? So we have different color, okay? So this larger triangle. So R is this section, but this is longer than R, right? For the hypotenuse of this larger triangle. But what we know is this is still angle X here, right? According to this diagram here. But what's this space here? This space is here, right? And what's this? This is the radius of the circle, right? Which is 1. So the base here is 1, okay? Now, what we know is, we can say that tangent x is equal to this side over 1. Let's label this side d then, okay? Then we're going to have tangent x is equal to d over 1. Then d is equal to 1 times tangent x. We have d equals to tangent x. Okay, so this is tangent x. Tan x. Okay? And we don't need this anymore. Now, what's the area of this larger triangle? Is the base times height divided by 2. So that is 10x times 1 divided by 2. Okay, as we know that, right? The area of this smaller triangle is less than or equal to the area of this sector is less than or equal to this area of the larger triangle. So we can write this, okay? Here, this, which is 1/2 sine x cosine of x, right, times cosine of x, is less than or equal to 1/2 x r squared is less than or equal to this, which is 1/2 10x. Okay, so multiply all of this term by 2 to get rid of the 1/2. We have sine x cosine x is less than or equal to xr squared is less than or equal to 10x. Now, knowing that, what is r squared? R is equal to 1. R squared is just 1 square. So it's 1. 1 times x is x. So sine x cosine x is less than or equal to x is less than or equal to 10x. Okay. Now, we see that the limit is supposed to be x. It's supposed to be sine x over x, right? What we can do is divide all this term by sine x, and then we do the inverse of all this term, right? So do this. Sine x cosine of x divided by sine x is less than or equal to x over sine x, right? It's less than or equal to 10x over sine x. Okay. Now, what do we do? Sine x and sine x cancel out. How about 10x over sine x? We know that 10x is equal to sine x over cosine of x. Then 10x over sine x is sine x divided by cosine of x divided by sine x, which is here, right? Then this cancel out. All I left over is 1 over cosine x. So this is cosine x is less than or equal to x over sine x. It's less than or equal to 1 over cosine of x. Now, we have to do the inverse of all this term here, right? Then the inequality sign has to flip, okay? So this side 1 over cosine x is greater than or equal to sine x over x. It's greater than or equal to now 1 over cosine of x is cosine of x. Okay, now the middle term looks like this now, right? And all I need to do is just take the limit for all these 3 terms, and I will get the middle term equal to the limit. So take the limit. Limit as x approaches 0, 1 over cosine of x is greater than or equal to limit as x approaches 0, sine x over x is greater than or equal to limit as x approaches 0, cosine of x. Now, the middle term is exactly what we want, right? For the limit now. Okay, now, let's evaluate the limit of the 2 terms on the side. Now, just plug 0 into x here is 1 over cosine 0, right? It's greater than or equal to limit as x approaches 0, sine x over x is greater than or equal to, now, this is cosine of 0. Okay, Cosine 0 is 1. 1 over 1 is 1. It's greater than or equal to limit as x approaches 0. We keep this term the same, right? Sine x over x is greater than or equal to cosine 0 is 1. Okay, now what do we see? Now we see that, right? If this limit is in between 1 only, right? Then this must equal to 1. So we can say that limit as x approaches 0, sine x over x is equal to 1. Okay, so we have this solved here, right? That's equal to 1, which is this term here, right? This limit here. Now, let's find out what this limit is equal to. So we have here limit as x approaches 0, 1 minus cosine of x over x. Now, look at this. We have an x at the bottom, which is similar to the limit we just found out, right? What we can try to do is utilize this limit here that we just find out to figure out the limit here for this one. To do that, we need sine x, right? How do we generate a sine x here? Now look at the numerator here, 1 minus cosine of x. Can you convert this in terms of sine x? You can. Well, we do know that, right? Sine square x plus cosine square x is equal to 1. Then sine square x is equal to 1 minus cosine square x. And of course, this is not the same as this yet. But what can we do to convert this into this? Now this, you can see that as 1 square minus cosine square x, right? So it's a difference of square. So what do? We can just multiply this limit by 1 plus cosine x over 1 plus cosine of x, right? Because this term is just equal to 1. So I have not changed the limit. So, but the numerator will become this, right? This 1 minus cosine square x, 1 minus cosine square x over the denominator will be x times 1 plus cosine of x. Now, 1 minus cosine square x is sine square x. So we can write that as limit as x approaches 0, sine square x over x times 1 plus cosine of x. Okay, now I can break up the sine square x into sine x times sine x. That's equal to limit as x approaches 0, sine x times sine x over x times 1 plus cosine of x. Now, I can break up this product now, right? Which is limit as x approaches 0, sine x over x times sine x over here, 1 plus cosine of x. Again, distribute the limit to both terms according to the property of limit. I have this. Times limit as x approaches 0, sine x over 1 plus cosine of x. Now, we just figure out that this limit here as x approaches 0, sine x over x is equal to 1, right? So that's equal to 1 times, how about this? We can directly plug 0 into x here. So sine x, right? So sine 0, right? Over 1 plus cosine 0. Now, 1 times sine 0 is 0, divided by, now cosine 0 is 1, 1 plus 1 is 2, right? 0 over 2 is 0. So that is equal to 1 times 0, that's equal to 0. Okay, so this limit here, right, is equal to 0. Okay, so now we have the answer here, right? So equals to 1/2 times this, we figure out as 1. That's 1. Times 1 times this is equal to 0. So times 0, right? This whole term, right, is equal to 0. Okay, so the answer to this limit is equal to 0. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.